Hello everyone, my name is Ashmal, and along with me we have our teammates Animesh, Vishal and Jay. And the paper we will be presenting today is Social Counterfactual. This paper is published at CVPR 2024. Currently this paper has 15 number of citations in total. Let's talk about the problem statements. Vision language model, or what we call as VLM, they have some inherent biases that often comes from the training data set it has been trained on. These biases can be social bias, stereotype bias, or some other sorts of bias. But they are often because from the unbalanced data sets that's been trained on. Some of the examples of them are gender, race, and some other social attributes that can constitute to stereotype biases. The current research that has been published, mostly they focus on single attributes of these bias types, such as gender or race only. And the reason for that is that the real-world images that can have such combination of those biases are pretty hard and expensive to find. This is where the concept of social counterfactual paper comes in. Social counterfactual dataset is a synthetic dataset of image-text pairs which spans across 171,000 synthetic images. They were the first one to introduce the concept of intersectional bias, and that's the main novelty of the paper. They only focus on 3 social attributes, which in this case is race, gender, and physical characteristics. They make a combination of them, and 3 intersectional bias pairs becomes race, gender, physical characteristics, and race and physical characteristics. Whatever the data set they came up with, they evaluate 6 VLMs on top of that, and that evaluation is retrieval-based, not the VQA-based. It is very important that we remember that. They present several conclusions from their evaluations, and one of the key conclusion is that the VLMs, vision language models, they have some social inherent biases in their when they're retrieving the images, because this is a retrieval set. Now let's start from start. What is intersectional bias? Like we said, existing works focus on single sort of bias, like gender, race, physical attributes. If you somehow club them together and have a way to represent that image that can have both of these bias, 2 or more, and you create a unique pair of them, that is what's called the intersectional bias. And just to note, the bias is both underrepresentation and the overrepresentation. For example, if you ask a query that retrieve the images for doctor, and it has a very less occurrence of black women being a doctor, that means it's just in bias, it's an underrepresentation. Similarly, if you ask to retrieve an image for construction worker and it fetches more number for Latino men, that means it's again a bias, which in this case is an overrepresentation. Counterfactuals and its importance. Counterfactual in general is something that could have happened. It's a statement that what if it was happened, but it never happened. Counterfactuals in machine learning is a study of effect of change on an original sample with the slightest modification. So you have an original sample, you do some slight modification, what is the effect of that? That is counterfactuals in machine learning. How social counterfactual treats it is they have a concept of subjects or occupations, and they have a concept of social attributes like gender, race, and physical characteristics. They try to come up with a pair and have a minimal change in them and tries to study what happens when we change one of the attributes among a social counterfactual set. For example, let's take a look at this image. We have an attribute 1 and attribute 2 in orange and green respectively. And we have a subject chemist, which will be similar across all things. We have a white male chemist, and you have an image for that. We have a white female chemist, and you have an image for that. And if you look at them, the only change between them is from male to female, which is only one physical characteristic. Now, if you have the image, next we have an image for a black male chemist and the black female chemist. And again, you see the difference of the gender in this case only. So you have a minimal modification of social attributes, and you try to understand what happens when you change them. Okay, VQA versus retrieval. Very interesting question. Existing works that we talk about, they focus on the VQA task. VQA, or visual question answerings, is a concept where given an image, for example, in this case, is an image of an art painting, and you have a question that you have to complete. The person who paints a painting is either a female, either a male. You ask a model question. And the VLM, vision language model, is supposed to answer with a particular word, which is called a next word token prediction. It tries to predict from its vocabulary. In this case, LavaView 1.5 came up with an answer for female. MiniGPT v2, they came up with an answer that, okay, it gives you a statement instead of a single word, but at the end saying that it's a woman. And same with cog-VLM, it's also saying that if it's a female. So whatever information that the model tries to produce without it being present in the context is something we call it hallucination. And why is it predicting the female only? It's particularly because it's being biased towards those that the good paintings, good artists can only be from the female gender. As compared to the concept of social counterfactual, which focus on the retrieval task. You have a query, a photo of a doctor, and you pass that to a clip model, and you have a set of images that you pass to the clip model. And clip simply fetches some top images that it finds, that it feels that it's just they're very close to the query. And as you can see that the clip is able to fetch multiple physical attributes pair, such as in this case, we have a white male doctor on the top left. In the top middle, we have white female doctor. Top where we have black male and so on, black female, Asian male, and Asian female. All of them are doctors, so that's where the query was, and it was able to predict it. This is called the retrieval task. Dataset curation. Our dataset curation that the author proposed is composed of 3 steps. Step 1, caption construction. In the first step, they try to come up with the caption as you can see on screen, which is a photo of wild male doctor and so on. For generating a captions, author has proposed a unique concept of counterfactual sets. And the set is composed of a prefix, which is in this case a photo of, attribute 1, which is white, attribute 2, which is male, and then you have a subject. Subject is also called occupation in this context. And they have used a combination of 260 occupations, 4 prefixes, 6 race, 5 physical characteristics, and 2 gender terms. And combining them, they came up with 54,000 captions, for which they were able to generate 5.4 million images before filterings. And they have this concept of counterfactual sets, which we talk about in the top, prefix, attribute, subjects, which totals for 13,000. Just make sure that this is before the filtering and they apply that in the next stage. Coming back to the pipeline again. Now step 2, once we have these captions, we want to generate the images for them. So they used stable diffusion for that. And they used them to generate the synthetic images. They're using different prompts, different prompting techniques. And what they do with a given caption, they make only one change in them, single attribute change in the prompt, like they would only change from white to black, male to female, and keep the rest of the things unchanged. They use a concept of over-generate and then filtering. So for each caption, they generate 100 images per caption, and later they perform the filtering on top of them. And again, like we said, that there is a concept of counterfactual set, prefix attribute set. An example for that is an photo of Asian male doctor, and there would be 100 images for them. So in total, this is how their stats looks like. They have like three combinations of intersectional bias, race, gender. They have like 104,000 sets and number of images per set, and the total is about 5.4 million images. This happens before filtering. After filtering, this total number of sets is going to go down by a lot. Last step, which they call as 3-stage filtering, it has like, of course, 3 stages. Stage 1, it's composed of clip, image, text, similarity filtering. And the key idea for this particular part, clip to image filtering, you pass an image, you pass a caption, and you try to compute the cosine similarity or clip score between them. And if the score is over 0.2, which they have set as a threshold, you keep the image, otherwise you discard the image. For example, you have a query, black nurse practitioner, and you have an image, and you have a caption, a black male nurse practitioner, and the clip score is very high, it's 0.846, which is as expected. You have another image, a black female nurse practitioner. Again, you have black nurse practitioner in the query. You have a pretty high clip score of 0.72 again. Next one, white female nurse practitioner, which is very different from what it was asked in the query. And the clip score is unsurprisingly low as expected. And then for, again, it's about Indian male nurse practitioner. It's again this small. The clip score is less than 0.2. We simply discard that image again from the set. And after image to text filtering, they do image to image filtering. So like we said again and again, there is a concept of counterfactual set. They want to make sure that between set, the images should be consistent. For example, both of these images are for the doctor, and the clip score is 0.34. But in this case, the image on the left is for a doctor, but in the image on the right is for the chemist. So the clip score is low. They discard that set from a particular set to have a good filtering. After stage filtering 1, like this is what we saw before. The total number of images that they were able to gather was 5.4 million images across 312,000 across 3 intersectional bias pairs. After filtering using clip on stage 1, they were able to filter out majority of the set, and that reduced from 312,000 to 21,000. And as you can see that on the right, 87% of the images from race gender pair were filtered out, same as 93% for physical characteristics and gender, and 99% of images for the physical characteristics and the race. Now, this is the second stage, which is NSW filtering with a VIT. And the concept of that, they use a pre-trained Hugging Face model, which is specialized for image classification that does not safe for work images. They filters it out, and using that existing model, they were able to filter more 0.9% to 2.7% of the images. So like we saw before, we had in total of 312,000 sets across all combination. It was reduced down to 21,359. But after stage 2, it further went down to 21,116, which is the second stage. Last stage, they have this concept of clip attribute detectability filtering. So detectability filtering is something that if you see an image and if you are given the social attributes, you should be able to tell that these social attributes particularly exist in the image. For example, in this particular visual sample, the query was a Middle Eastern female construction worker. And as we can see, that the model was unable to generate a concept of female subject. So this image becomes undetectable. And another image where Stable Diffusion generated for a query a picture of an Asian female roofer. And as we can see that it could not distinguish between the gender. It's not a female, it's a male. Again, a white male nurse, and the model again fails to generate male nurse because maybe it has not seen such examples in the training set. And last, that the black female of CEO, and as you can see that there's no central in the frame, there's no object in the center of the frame. So this makes the image or the particular example undetectable. So for that, what they do, they have a two-step process. One is human verification. So for every counterfactual set, they manually label 100 images for them. And for each set, they use a different threshold. Let's say for something, the threshold was that it should be in a center. For some, the threshold was the clip score should be greater than 0.3, not 0.2. And they try to learn these heuristics to an automated manner. So they label only 100 and they apply it in the rest of them. And after that, and again, like we saw, all of them are wrongly detectable images. And like we discussed, we went down from 21,116, which was the output of stage 2, to further 13,800 images, which is the final output of stage 3. So these are the total number of sets, which totals about 171,000 images that they have used for the remaining process. Now let's look at some qualitative examples for race and gender attributes. So with a small modification, such as on the top left, a photo of white male chef, and you can see the image, and then white female chef, black male chef, black female chef, Indian male chef, and Indian female chef. So have like a one attribute difference each, and they give some qualitative examples for, again, white male nurse and female nurse, like we saw. And there's, again, an image of white male chemist, female chemist, black male chemist, black female chemist, and again. Another example for characteristics gender attribute, they have the skinny male civil engineer, skinny female civil engineer, young male civil engineer. So all of them have like a one attribute change. And the next, skin carpenter, which is an occupation and also in subject, and they have one change for female. And then others are tattooed and non-tattooed and skinny and old. And the last is a cleaner. They have different variations for that. And last combination, which is the characteristics, physical characteristics, and the race attributes. And they have for different color and different race. One is Latino, Middle Eastern, Asian, and young, and pharmacist. So as you can see in all of them, the subject or the occupation is same, but the social attributes, which is physical characteristics or race, is with a minor modification. All right, now I'll pass it on to my next colleague.
So the goal of this paper was to measure bias within VLM models. To measure this bias, they have two particular metrics, which they say skew at k and max skew at k. We'll go into the details of both of these. They use retrieval-based tasks, that is, they try to retrieve images from a data set using these VLM models. So this would be the formula for skew. We'll get into the details. AI and AJ are our attribute pairs that can be race and gender, race and physical characteristic, or gender and physical characteristic. K is the total number of images that we want our model to retrieve. That can be any number 20, 15, or any random number that you would like to pick. Q is our query for retrieving. That could be an occupation, that could contain the race as well. An example would be, please give me an image of a doctor, or please give me an image of a construction worker. Our KQ is the total number of images retrieved, the entire set, given this particular query. So assuming that we have a K of 20, a query of doctor, then our set would contain 20 images of doctor from the data set. The entire numerator for a logarithm is the percentage of retrieved images that contain the attribute pair that we are looking for within that particular K number of images. The denominator is the percentage of images for the given attribute pair and the query within the entire data set. If the skew value is 0, we conclude that the VLM is unbiased for that given query and that given attribute pair. However, if the skew value is not 0, we can conclude that the VLM is biased in some extent. An example of this would be assuming that we have a query of a female accountant, and we want a model to retrieve 12 images. That's why the value of K is 12. Our attribute pair for this example are Middle Eastern and female, that is race and gender, but for our entire project, there can be anything using any attribute pair. DQ is the total number of images within the data set of an accountant. So give 200, in the entire data set, we have 200 images of female accountants. And DQ AI of AJ is that 20 images, which is basically we have within those 200 images, we have 20 images of accountants who are Middle Eastern and female. Our RK is our 12 retrieved images. Then if we go on to calculate our numerator and denominator, we can see that within the particular set of images, the 12 retrieved images, assuming that we have 4 Middle Eastern female accountants, we can calculate that we have 33% of the retrieved images are for this particular attribute pair. However, ideally, within our entire data set, since we only had 20 Middle Eastern female accountants among 200 female accountants, the percentage would be 10%. Calculating this using our formula, we get that the logarithmic value comes closer to 1.20, to which we can conclude that the model is biased towards Middle Eastern females when the occupation is accountant. MaxQ is going over all the sets of attribute pairs for a given occupation and getting the maximum value of skew, which would conclude that this is the highest amount of bias that the model can go up to. The higher MaxQ value, which means there is more bias within the model. An example for this, for any given occupation, assuming doctor, if we have these physical characteristics, these physical attributes, then white male has a skew score of 1.29, black skinny has 0.247, and so on and so on. We can see that for Middle Eastern old, we have a higher skew score, so our max skew score would be 2.368. We use this value particularly to then measure how much a model is biased for a given occupation when compared with other models as well. A simple explanation of box plots. For a box plot, the middle center higher box contains the main data from the 25th percentile to the 75th percentile. The bolded line would be our median, which is our 50th percentile, and the dotted line is our mean. The t value that you see at the top and bottom contain the first 25 percentile and the final 25 percentile data. There are also certain points outside of these t values which we count as outliers. So let's go into the evaluation of these models, some of these models, using our MaxQ analysis. So for this particular attribute pair, race and gender, we pass all our occupations within the models, and we get this particular diagram. So we can see that clip and flower show the least amount of median scores, that is they have a lower bias when compared to the other models which have a higher max Q value for the same data. A-lip has occupations, that is laborer with zero skew, that is when given the laborer occupation, it does not show any bias towards any particular race, gender, and so on. As we can see, some of these points are outliers and marked in red, while others are marked in green. The greens ones show a lower bias, while the red ones show a higher bias when the model is asked for those particular occupations. Similarly, we check this for attribute, physical characteristic and gender attribute pair, and we can see that flower has the lowest median bias, as we can see it's at the very bottom, while clip this time has median bias on the higher side of the box. Similarly, all the others have a higher bias than flower, and la clip, open clip and slip show consistent bias across all pairs. So as we can see, they have a similar bias box plot when compared with A-lip, which has a higher variance, and clip and flower, which are also consistent within their bias frames. Next we go into the other attribute pair, which is physical characteristics and race. In this we can see that flower again has the lowest median bias. However, since we can see that there is a very higher outlier which is at the top of the chart, we can say that it has a higher variance of bias given this particular attribute pair. Security guard, as we can see, the particular occupation shows consistent low bias for these three particular models, namely A-lip, clip and flower. So we can assume that security guards have, within the data set, security guards have a higher number of attribute pairs of physical characteristic and race. So let's look at some quantitative analysis. So in this chart we are asking the model to retrieve the images of doctor, and these are the races that they want to check. Open clip and la clip show a higher skew, that is when we see that they only show 3 races among the 6 races, whereas flower shows the lowest skewness because they show all the races given the occupation of doctor. Next we check for gender distribution within the occupation of doctor, and we can analyze that slip, open clip and la clip only show male gender, that is they have a higher biasness towards showing male doctors and are not showing female doctors at all, whereas flower and clip have a lower gender skew, showing more female doctors as well in retrieving. Next we form attribute pair of race and gender and try to get more images for doctors. We can see that only flower shows black female doctors, whereas the rest of the data set doesn't show any female doctors when retrieving images. Open lip and la clip have the highest biasness, as we can see that they have very few combination pairs, only 3 of them, and the rest are not being shown. So this was for pre-trained VLMs. The paper then go into training the VLM models using the social counterfactuals dataset. So this is our data split pipeline. We have our entire dataset containing all our all our attributes, and we split them by subjects. So we have an 80% split of training set and a 20% split of testing set, which contain different occupations than the training set. What do I mean by that? As we can see, if the training set contains nurse practitioner, female chef, plumber or chemist, then the testing set would not include these particular occupations at all. This would showcase later to show that the models can actually apply the same concepts when they have not seen those particular occupations. Next we go into model fine tuning. We take our training set and then we fine tune them on these 3 particular models, namely clip, A-lip and flower. Using our de-biased model variants, we then evaluate max Q on the testing dataset. This would be our entire training pipeline, and just in case anyone has any questions regarding those. After the training, we can see that there is a definite change in the model's biasness. So this would be the pre-trained max Q values for these particular attribute pairs, whereas after debiasing, there is clear difference within the max Q value, that is the model shows less biasness towards many different attribute pairs. As I said before, the training and testing set data do not have the same occupations, which shows that bias generalization to unseen occupations is quite possible using this training data set. Some other results. So since we know that these images are synthetic, what about the real world bias? The authors also test on the VSHO gender and PETA data set, and using pre-trained model we have a higher skew value, whereas after the debiasing training we have a lower skew value. The VSHO gender data set is a data set which focuses mainly on gender using image text pronoun resolution, whereas PETA contains images of different races, genders and ages. Next we have a retrieval based approach. So when retrieving the model, so we also test the models on task retrievals, which is text retrieval and image retrievals. To give a general idea of what retrieval is, given an image and a list of captions, we pass it into debiased clip. R at 1 is basically getting the most similar caption, whereas R at 5 get 5 most top captions, and R10 gives us the 10 most similar captions to that image. We can see that the model gave us our debiased model gave us a higher accuracy when doing text retrieval, and if we keep going in terms of image retrieval, we can see that there is a slight reduction in the accuracy of this retrieval of the debiased models. Similarly, when we test our clip, debiased and pre-trained model on various other data sets, we can see that there is another reduction in accuracy as well. However, this particular accuracy is consistent with all other works of debiasing. So this is a natural trade-off between performance and fairness for the model. Some of the limitations the authors discuss within the paper is there is a latent bias between the caption template and experimental setup. That is, some of the captions may contain inherent biases themselves, which the model may learn eventually. Another one would be binary classification of gender. As we know, gender is perceived. However, for the sake of this data set, they only split it into two, which is male and female. It does not encompass all races, physical characteristics and occupations, and also exclude if the model is asked for biasness against certain groups which have not been included in the data set, they would definitely show a higher or lower bias. Categories are not representative of groups, which is that all the occupations are not necessarily similar to all races and genders and physical characteristics, so the results only reflect a small amount of group from the entire data set. Thank you very much, and we'll take any questions.